In the previous video, we defined a data structure dictionary and accessed the values which are associated with keys. In this video, let us learn to apply the different methods to retrieve the keys, the values and the key value pairs. Let us apply the operators to check whether the key or a value present in a dictionary. Although we use a special methods get and set default to check and insert a new key value pairs in the existing dictionary. Finally, let us identify suitable problems which can be solved effectively with the help of dictionaries. The useful dictionary methods. We have three dictionary methods which will return a list like structures containing the keys, values and key value pairs present in a dictionary by applying keys method, values method and items method respectively. As I said, the values returned from these methods are not true list, they are list like structure. It means that we cannot modify the contents of these list like structures called dict underscore keys, similarly underscore values and underscore items. So these are the list like structures returned from keys, values and items method. A keys method will return a list of keys present in a dictionary, and the syntax to access this method or to make a reference to this method is dictionary name dot keys. Similarly, values method will return a list of values stored in a dictionary. Let us take up one example. Here we have a dictionary with two items, and to retrieve all the values present in a dictionary, that is red and 42, we have to use a values method spam.values, and we have to iterate through the list like structure that is returned from spam.values to print all these values. Similarly, to print all the keys present in a dictionary, we have to use a method called spam.keys. This will return a list like structure containing all the keys, and we can iterate over each of these items, that is keys, to access and as well as to display these keys present in a dictionary. The third method is the items method, which will return a list of tuples containing key value pairs of a dictionary. We can use a for loop to access each of the key value pairs returned from the items method. Let us take up the example. To access this key value pairs from the dictionary, we have to use the method called items. This will return a list like structure containing the tuples, and we use for statement to iterate over these items which are tuples. And this is the effect of a print statement, where print will print each of the item wherein the item is a tuple containing two elements. If you want to create a true list from the dictionary methods like keys, values and items, what you have to do is you have to pass this list like structure, which is returned from keys, values and items, to a function list, and this list function now will create a true list which may be modified by the programmer at runtime. Remember, we need to pass these methods like keys, values and items which return a list like structure to the method list, and this list will generate a true list for further processing. Let us take up the example to illustrate the use of list method in association with the dictionary methods. We have the dictionary spam with two elements, and if you access the keys of a dictionary with the keys method, this will return a list like structure with the name dict underscore keys containing these two keys. Remember, this list like structure is read only. We cannot modify these list like structure by adding or by inserting or appending new elements. In order to generate the true list from these keys method, what we have to do is we have to pass this list like structure generated from spam.keys as a parameter to a list, and now if we print this list, we get the true list. And at this point, as a programmer, we can insert or append new elements to this list. We can also use a multiple assignment trick within a for loop to assign a key and value of a dictionary item to a separate variables. Let us have a look. Here we have a dictionary with two elements, items, and spam.items returns a tuple containing key and value, and this key and value can be assigned to a variable k and v respectively. Thus we can store these individual key and value of different tuples within a for statement, and we can process them individually. We can apply the in and not in operators on dictionaries to check whether a certain key or a value exists in a dictionary. We'll take up the previous example having dictionary with the name spam, and let's check whether the key color is present in spam with this statement, and it returns true as color is a key in the dictionary spam. And let's see whether red, that is a key, is present in spam. It returns false because we don't have a key called red. And let us see whether the key age is in spam by applying a keys method. This will return a list like structure, and we can apply in operator on list like structure. It returns true as there is a age is a key. And let us apply not in operator. Definitely this will return false. And let's check whether 42 is a value in the dictionary spam. What we have to do is we return the list like structure from spam.values and then apply in operator, and this returns a value true because 42 is found as a value in the dictionary spam. We have a special method in dictionary called get method. This is very useful and popular method. What it does is it takes a key as a first parameter and the default a value as a second parameter and returns the value at the first argument, that is a key, if key is found, and in case key is not found, then it returns a default value that is supplied as a second parameter. Remember, get method will take two arguments. First is a key and second one is a default value. It returns a value provided key is present in the dictionary and returns a default value if the specific key is not found in the dictionary. Let us take up the example. Let us take up the dictionary age with the name as a key and the age as a value, associated value. We have three items here and we want to know the age of a person, Bob. What we have to do is we have to use a get method, age.get, and pass two arguments, the key, that is the name of a person, Bob, and the default value, that is a 0 if the age of Bob is not present in the dictionary. That means the record of Bob is not available in the dictionary age. And this function will return 55 because the key, that is Bob, is found, and get method will return the associated value 55. Let us apply on a Tim. Tim is not found in the dictionary, thus no availability of a key as well as the associated value, and this get method will return a value 0, that is the default value that we supply. Even we can specify negative values as an indicator of unavailability of a age of a person, as the person's details are not present in the dictionary. Let us take up two more examples. Here we have a dictionary called picnic items with two items, and you can appropriately use this get method to retrieve the number of cups, and you get 2 here. And if you use it on eggs, as eggs is not present, how many items are there? Only we have apples and cups, no eggs, thus it return 0, and we have a meaningful message showing I am bringing 0 eggs. Let's take up the third example where we specify the eggs in the form of a index operator, as we don't have the eggs in the dictionary picnic items, and this will return or produces an exception, that is a runtime error. In order to safeguard from this kind of runtime errors, it is better to use a get method with a default value. Even though this the key eggs is not present, it will not raise an exception or a runtime error. It will return a default value. Remember, whenever you are not sure of the key that is being present in a dictionary and you want to access the value, do not use this index operator. Better, you are advised to use a get method to retrieve the value provided key is present. Otherwise you will get a default value that you are supplying to a function. Thereby you will come to know the unavailability of a particular key in the dictionary. We can add new items onto the dictionary provided the key of the new item should not be present in the dictionary. To ensure the unavailability of the key in a dictionary, commonly we use an in operator like this. Here we have a span with two elements, and to add a new item with the key color and the value black, what we have to do is first we need to check whether this new key, that is color, is not in the dictionary. Then only we are allowed to add this new item. And in operator is a best choice to check whether the key is present in a dictionary. And if this key is not present in a dictionary, then use an assignment statement along with the index operator to add a new key and its associated value like this, span of color equal to black. And this can be replaced, the same two-line code can be replaced with the single line code with the help of setDefault method. What is this method? This method takes two parameters like a get method. First one is the key to check for, and the second argument is the value that we are going to set for the first argument, which is a key. And if key exists in the dictionary, then the setDefault method will return the key value from the dictionary. Otherwise, it inserts the new key and its a value. That's the second argument of setDefault method. And this method is a good shortcut to insert a new item with a key by checking whether the key is present or not with a single line of code. And the frequency counter problem is the best example to apply this in operator and to apply the get method, and also we can use this set default method to solve this frequency counter problem. Let us illustrate the use of set default method by taking one example. We have a span dictionary with two keys, name and age, and we want to add a new key and value pair with the set default method. And this method will return the newly added value as well as inserts this new key color and a black. This is what the dictionary contains after this first set default method. And again, let us use a set default method to create one more item with the existing key color, and we change the color to white. And this will not happen because the color is already present as a key in the dictionary. And this set default method, if the key is present in the dictionary, set default method will return the associated value of this key. Otherwise, it insert this new key and the value. In this case, it just returns black, and it will not change the key value, that is color, to white, as color is already present. And if you see the contents, it remains same, as there is no assignment of a white value for the existing key color. Python provides a module called PPrint, which has two functions, PPrint and PFormat, which are used to format the printing of dictionary values. The traditional way of printing, that is with the help of print function, we may not get the cleaner the print or the output of the dictionary values. The Python PPrint function will facilitate the programmer to decorate the output of dictionary values. Especially this function is helpful while printing nested dictionaries or nested lists in a proper format. Here is an example wherein we import the PPrint module and we use a PPrint function to display this dictionary, which is a frequency which holds the frequencies of individual letters of a given message, which is a frequency counter or the histogram of letters. Let us take up the programming examples. First one is the frequency counter problem. This is well-known computational problem. Suppose you are given a string or a set of items and you want to count how many times each letter appears in a string or how many times each item appears in a given set of items. This problem is also called as a histogram problem in a statistical terms, wherein we are going to come up with the count of frequencies of individual elements of a given set of data elements. There are several ways to solve this problem, maybe implementation ways. Which is the best data structure? A list is not a suitable data structure. Even one can solve this problem with the list, provided for every time, for every encounter of an element in a list, we need to search a particular cell in the list using either a linear search, and this is computationally expensive activity or the operation. And the best data structure for this frequency counter problem is a dictionary, where we don't have to search the element in a like a list in a linear way. We can place the frequency of an element as a dictionary value, wherein key is the element itself and the value represents the frequency. And on every iteration for every value, we identify the dictionary key value pair and we update the value with the assignment statement. This is how we can solve with the frequency with the help of a dictionary. Here is a code. We have a set of characters, letters. This is a string. What we do is, first we create an empty dictionary. You can even use braces also, and you read each letter one by one. This what this for loop does. We read each letter from this string, and you check whether the string, this character or a letter, is already present in a dictionary. How do you check? You have to check with the in operator, and here it is the not in. If this letter is not in the dictionary, that means it's a first occurrence. That's the first occurrence of a letter, first appearance, while moving from left to right of the string. And if it is the first occurrence, create the dictionary entry with the D of C. C is the letter, equal to 1. That is a value. Letter is a key at the dictionary D and the value is 1. This is the first appearance. And if it is already present, if C is not in D fails, that means it is in already, it appeared while encountering all these letters, it has entry in the dictionary. Then we have to increment the counter. That becomes the second second encounter frequency becomes 2, and the third appearance 3, etc. And this else part will increment the value of a dictionary cell at a particular key, which is a letter. This is a very simple program. For each of these letter, you check whether letter is already found in the dictionary as a key. If it is not found, it is the first appearance, initialize the counter to 1, and all the subsequent appearances you increment the dictionary value at a key, that is the letter, by 1, so that at the end if you print the dictionary, it's nothing but a histogram where you, for each of the character, you will get the count, how many times a particular all these letters appear in the given line of text or a given string. This is the second implementation method, wherein we are using a get method, and we have avoided here if else structure. What we do is, again we check each of the letter, and if for each of the letter we check whether the C is present as a key. If it is present as a key, it will return the value at that particular key. That means it is a subsequent occurrences, wherein we increment the existing value by 1 and we replace with the new value. And if it is a first occurrence, the default value that we are going to give 0. If key is not present in the dictionary, there is the first appearance, and the existing the frequency is 0, and the new key, that is this new letter first appearance, will be inserted onto the dictionary with the value 1, because this get C comma 0 will return 0 as the letter is not found in the dictionary, and thus we assign or initialize the counter value with the 1. And for all the subsequent appearances, we are going to increment the counter, there is the existing value at that particular letter, by 1. Thus, if you print the dictionary, again we get the histogram, that is the frequency of occurrences of each of the letter. Let us take up the third implementation. Instead of using get method, let us use a set default method. This is again a similar method like a get, where it inserts the new key C, provided if it is not there, okay, and if it is present, then it will return the value, and we are not using that value for any of the purpose. And for all the subsequent what we say subsequent occurrences, we increment the value. And for the first occurrence, what we do is we create an entry with the new key, that is a C, that is a new letter with the value 0, and here it is get incremented. That means the frequency of the count of the first appearance becomes 1, because the d of 0 that is being created by this set default is 0, and 0 plus 1 becomes 1 for the first appearance, and all for the subsequent appearances this will just return the value, and we are not using that value, and we are reading the value with d of c here. Thereby we increment the counter, frequency counter. So these are the three different ways of solving this frequency counter. One is with the just in operator and if else structure, and second one is with the get method, and third implementation is with the set default. As a programmer, you can choose any one implementation strategy to solve this frequency counter problem, either of characters, of numbers, or any other even tuples, or any other type of data items. Let us take up the second problem: student database maintenance and accessing student details given the student roll number. We can implement this in different ways with the different data structures. Let us take up the first alternative, that is a list. We have to define a list of tuples where tuple contain USN, name, branch, marks, and each tuple is placed in a list. The problem with this implementation is a search. For example, we want to search a particular student based on his roll number or seat number. We need to search the list from the beginning for the given USN, and once we have found the USN, we can retrieve the entire tuple at that particular location. And this is a linear search. Even one can apply binary search provided all these records are sorted based on USN. And accessing the student information is costly in terms of the computation. And the best data structure, alternative 2, is a dictionary. How do we implement this with the help of dictionary? Here we have to create a dictionary of tuples. And what is the key for this dictionary? The key for this dictionary is a USN, roll number is a key. And what is the value at that key? Value is the name, branch, and marks. And whenever the student USN is given, we can directly access the value at that particular key, because key is a USN, and within no time, without any comparisons, we can retrieve the student details. And this is the best implementation strategy to implement to solve this problem. Let us see the solution. Here is the Python solution. We have a function to read a student information, USN, then student full name and a branch and the marks of type integer. And this function will return a tuple having USN, name, branch, and marks. And here is the main segment. We create an empty dictionary of tuples, and we read total number of students, student count, and for each student from 1 to n students, we make a call to a function n times. Let us say if there are 10 students, 10 times this is called, and this function will return the student information that is read from the console, and we are going to assign it to 4 variables. This is a trick of a multiple assignment. this tuple value is assigned to these 4 variables. And after assigning to these variables, we have to insert this student information onto the dictionary. For that, we need to check whether already that particular student's details are available in the dictionary, that is using not in function. If the USN is not registered in the dictionary as a key, that is a DB is a dictionary, what we have to do is we have to add the new item onto the dictionary with the new USN, and the value is a tuple containing 3 items: name, branch and marks, and the USN is a key, and this has to be repeated for all these n students. And now we have a database which is indexed with the USN, and let us say we want to retrieve the data of a particular student by reading the USN. Only thing is we have to use the in operator, give the USN to be searched to this if statement. If search is in DB, that means if this USN, that is a search USN, is present in database as a key, then return all the values at that particular key. How do you extract these individual tuples? The same way of a 2-dimensional list. Here we have to use a dictionary name, and search is a key. Okay, that's a USN, and 0 is the first element, that is nothing but a name of a student, and index 1 is nothing but branch, and index 2 is a marks. This is how, by having 2 index operators, subscripts, we can access the individual tuple elements which are stored against the key USN. And this is actually computationally efficient implementation, as we can search the student record without any series of comparisons with respect to the stored USNs or stored student details. Let us summarize the discussion. We used dictionary methods called keys, values and items to retrieve the set of keys, values and key value pairs from the dictionary, and we have checked for the existence of a key or a value, whether it is present in a dictionary. At the same time, we used a method get and setDefault to insert the new keys onto the dictionary with the values. Finally, we solved 2 problems. One is a frequency counter problem with 3 different alternatives, and then we found a solution to a student database and student information access problem, which is implemented as a list of or as a dictionary of tuples. With this, the learner or a student is in a position to choose a suitable data structure by analyzing the problem or problem description. Thereby, one can provide an efficient solution in terms of memory consumption as well as the computational speed.